Hello, I'm Jack Rickard. This is Electric Vehicle Television. Bob Wilson, who's been here for a month or two, has returned to San Jose, California, his girlfriend and his daughter. It's all good. We're on good terms, but he's not going to be here at EVTV much in the future, maybe an occasional guest spot. We're back to me, and it's all about me and Tesla. Let's talk about Tesla a little bit. They have, we didn't have a show last week. We ran out of me. And in fact, this week is my birthday, Friday, July 24th, 2015. I was born about noon on the same day in 1955, year of our Lord. It was 104 degrees that day at noon, and it is at least somewhat cooler here. I have now completed 30 dual orbits around the sun, double laps, making me 30, I think, in the 60 years since then. And so we're going to continue anyway, a few more miles before I sleep, I hope.
From the energy of the atom, invisible to man's eyes, to the vastness of the universe, staggering to his intellect, the frontier of science stretches forth, and the men of science strive to press it back, patiently, tentatively, step by step. Two of the major challenges on this frontier of science are the exploration of outer space and the development of sources of energy. And two men who can tell us about these areas of progress are Dr. Guy Suits, a leader in scientific research, and Dr. Leo Steg, space scientist. To tell us about progress in energy generation, here's Dr. Suits, director of the General Electric Research Laboratory.
Energy is an extremely important driving force in modern civilization. The energy that we have available to us on the farm and in the American factory and in our economy, the mechanical energy, the electrical energy, this energy is the reason for our high standard of living. It makes it possible for one man with his one-man power to produce a great deal more than he needs for his own use. So the subject of energy generation, energy conversion is going to be important in modern American industry and in the laboratories of American industry for the indefinite future. We have to have more and better ways of generating energy, more efficient ways of doing so. Now, the bulk of our electrical energy, which is the most important form of energy in modern civilization, is produced today by the turbine generator. The starting point in generating electricity in a turbine generator is, of course, a fuel. In this case, one of the fossil fuels, so-called coal or oil or gas. With this fuel, we generate heat, which generates steam in a boiler, which in turn drives the turbine. You may think of the turbine as being a kind of a windmill. It has vanes like a windmill, and the vanes are driven with a high pressure and high temperature steam to rotate a shaft. The shaft drives the generator, which is a device very much like an electric motor. It produces the electricity which goes into the transmission line that you see here. And this, of course, finally brings the electric power into the home or to the factory or onto the farm. Now, the turbine generator produces about 90% of the world's electricity. It's a very effective and efficient method of producing bulk electricity. Nothing else has been able to compete with it to date. About 40% of the heat energy that goes into this system comes out over here as electrical energy. That's a high conversion efficiency, as we say. A turbine generator has some disadvantages, too. In order to have this high efficiency, this system must be large. It isn't possible to make a small, efficient turbine generator.
Tesla, in the meantime, has announced some serious upgrades, and I mean really quite serious, to both their car, their business model. A number of things are evolving at Tesla rather quickly. All of them good to my way of thinking. They have adopted the Panasonic silicon anode battery cell, giving them a larger cell for their battery pack and expanding their battery pack to 90 kilowatt hours. They've coupled that with a thing he calls ludicrous mode, and we'll see if we can work in a little Spaceballs Rick Moranis clip of that so you can see where it comes from.
Prepare to attack.
Prepare to attack!
On the count of 3. 1, 2, late!
What happened? Where are they?
I don't know, sir. They must have hyperjets on that thing.
And what do we got on this thing? A Cuisinart?
No, sir.
We'll find them, catch them!
Yes, sir. Prepare ship for light speed.
No, light speed is too slow.
Light speed too slow?
Yes, we're gonna have to go right to ludicrous speed.
Ludicrous speed. Sir, we've never gone that fast before. I don't know if the ship can take it.
What's the matter, Colonel Sanders? Chicken?
Prepare ship! Prepare ship for ludicrous speed. Fasten all seatbelts. Seal all entrances and exits. Close all shops in the mall. Cancel the 3-ring circus. Secure all animals in the zoo.
Give me that, you petty excuse for an officer. Now hear this. Ludicrous speed.
Sir, hadn't you better buckle up?
Now buckle this. Ludicrous speed. Go!
What have I done? My brains are going into my feet. What the hell was that? Spaceball 1. They've gone to plaid. We passed them! Stop this thing!
We can't stop. It's too dangerous. We've got to slow down first.
Bullshit! Just stop this thing! I order you! Stop!
Here, let me help you, sir.
Are you all right, sir?
Fine. How have you been?
Fine, sir.
Good.
It's a good thing you were wearing that helmet.
Yeah.
What should we do now, sir?
Well, are we stopped?
We're stopped, sir.
Good. Well, why don't we take a 5-minute break?
Very good, sir.
Smoke if you got 'em.
Elon is very good with various science fiction allusions and so forth. Ludicrous mode now drops the P90D variant from 3.1 seconds to 2.8 seconds, and that is indeed ludicrous. It's quite fast. Quarter mile time is cut to 10.9 seconds, and the maximum acceleration will be 1.1 G, or as Musk noted, faster than falling. You can actually get up to 1 G in a turn, which is a sensation most people have never felt. They made some suspension changes, upgraded the battery pack. They did a little bit of a change in some fusing, allowing them to put 1,500 amps into that motor. And at 400 volts, that's 150,000 times 4 would be 600 kilowatts of power. And so it just makes it a monster. They've also been under some criticism in kind of revising their talking points about the supercharger network. And I kind of found out what was going on there. One of the guys in New York was talking about it and them picking on him because he was charging at the supercharger network instead of at home. That's not really what's driving it. Whenever you offer a good deal, no good deed goes unpunished. And likewise, Tesla's supercharger network. The Schiphol Airport in Amsterdam has decided to use the Model S as their taxi service, and they have put 167 of them in service. They charge them exclusively at the supercharger network, which means that the supercharger station at the Schiphol Airport you really can't get into. It's been taken over by the taxis at the airport. Electricity in Amsterdam averages 28.89 cents per kilowatt hour at 50,000 miles per year. This would amount to about $46,000 in electricity over the course of 8 years, which is a significant percentage of the value of the car. The supercharger network and the Model S and none of Elon Musk's vision included taxis having free energy for life. And so they're kind of revising it from free charging for life to free long-distance travel for life. And you can see now why Musk prefers SpaceX, which is privately held, to the publicly traded company where he's constantly battling this sort of thing. He does, by the way, own 27% of Tesla, but has total control over it, which I think is kind of a cool thing. Let's see. I think I've got some more Tesla. That's more Tesla, so I must have some other Tesla. Let's see here. This is actually very good. If you will recall, we profiled a man and included a video of Jeffrey Don, a lithium-ion battery researcher and professor at Dalhousie University. I noted that Tesla had done a deal with Dalhousie University a couple of weeks ago. What I didn't put together was that this is the same Jeffrey Don who was doing some very good work measuring lithium-ion cells. And one of the things he was working on was a process of comparing the round-trip recharge efficiency and the remaining capacity of the cell, that he was about to work out a way to predict capacity loss based on the round-trip, very carefully measured discharge energy compared to the energy it took to recharge the battery. And I was fascinated by that work and by Dr. Don. And it appears he has entered into an exclusive partnership with Tesla, commencing when he completes his current 3M research project, which is right now. And it's a 5-year exclusive partnership with Tesla. Now, they're going to try to work out how to improve batteries, and I think that may be a very interesting move. According to Barron's, Jefferies analysts Dan Dolov and Trevor Young have come up with a huge figure based on conducting a survey with 145 Tesla owners and their likelihood to buy Tesla in the future, and factoring in some decreasing prices over the next few years. And they think over the next 20 years, Tesla has a potential market of 19 million cars. 85% of Tesla owners reported their next vehicle would be a Tesla, and 83% reported they would recommend them to a friend. A quarter of them didn't declare they won't even consider a car that's not a Tesla in the future. And so the We've been on a thing about depreciation in the cars coming off leaf. European auto information company Glass Information Services reports on Europe, and they're having exactly the same thing. Remember where you heard it first. This is getting to be a theme now. The Renault-fluenza, or as we call it, the influenza, tops the list of the worst depreciating cars, according to Glass. It holds 27.21% of its value after a year of ownership and 12,000 miles. You can buy one for just over a quarter of their asking price 1 year later, not 3 years later. But they have some. The Citroen C0 is number 4 on the list. The Nissan Leaf. Both of those hold about 33% of their value after 1 year. The C0 is a rebadged Mitsubishi IMEV. They retail for £26,766, about $1.50 to the pound. If you had bought one a year ago, it would now be worth $8,583 or pounds. I believe that's the car that Gavin Shoebridge was able to purchase in Slovenia. There is a new kid on the block, Faraday Futures, claiming that they're going after Tesla with a high dollar electric car. And this has been completely in stealth mode. They have funding, but apparently they have over 200 employees. And among them are kind of some serious players. Let's take a look. Nick Sampson is the product architect. He's the former vehicle and chassis engineering for Tesla Model S. Well, there you go. So the movement between Apple, Google, Tesla, and now this Faraday continues. Richard Kim is the head of design. He's a former BMW i8 concept manager. Silva Hittai, senior director of powertrain, a former lead powertrain at Chevrolet's Volt program. Pontus Fonteas, interior design coming to them from Lamborghini, Ferrari, and Land Rover. Paige Bierman, an exterior design chief, former creative director at BMW, and designed the 3 Series GT. Porter Harris on batteries. He's coming to them from SpaceX. The car is supposed to have 15% higher specific energy than a Tesla Model S, about 98 kilowatt hours. Multi-cell solution like Tesla's. Single groups of cells can be replaced, and the module is designed for mass production using new processes and technologies. Same battery designed to be used in all vehicles, and they're going after Tesla. This is significant. I don't know that Faraday will make it or not. Starting a new car company is a big deal, and Tesla is the first one to succeed in many decades. But it kind of goes along with the theme that we've been preaching from the beginning. This is not what it appears to be. General Motors and Ford and Chrysler and BMW and Mercedes and Toyota truly believe that Tesla is a disruptive force that is trying to come in and compete with them and take market share away from them. I understand why they would think that, and I understand their concerns. However, it's much worse than they believed. Tesla has no intention of coming into the automotive marketplace and taking market share from BMW, Mercedes, Toyota, General Motors, and Ford. They're there to eradicate it. There's not going to be a General Motors. There's not going to be a Ford. They're going to join Exide Battery and Eastman Kodak. and the Studebaker Wagon Company and Detroit Edison. This is where it's going to go, is companies like Faraday. This is the second. And I won't say they've made it, but they have a serious amount of money and the right people to do it. They're remaking the concept of the manufacture of a car, but way beyond that. They're remaking the concept of how to sell a car, how to buy a car, how to service a car, and what a car is. And it's a much more profound and disruptive evolution than BMW and Mercedes and Ford and General Motors imagine. They think they have to compete with Tesla. It's like the Burlington Railroad putting wings on their trains to go after Donald Douglas and the DC-3. This is not going to work out for them very well at all. And literally hundreds of thousands, if not millions of jobs and $85 billion in market are at stake. But the outcome, to my way of thinking, is pretty clear. There will be a lot of Faradays and many more Teslas, and they're going to be using SolidWorks and Silicon Valley and the web and the online community and so forth, and the whole model of dealers and so forth, the way it's done in Detroit is not under assault. It's obviated. It is no longer useful. I call it the Walking Dead. Cable TV is the Walking Dead. Even cable TV realizes that now. They're scrambling to become the default internet service provider. That's not going to work out for them either if Elon gets his Skynet up. These people are visionaries and innovators and non-trivial. And at this point, they've had enough success on the internet where billions of dollars are being thrown around. And the scale of this is almost incomprehensible. Note that the U.S. government had to loan or guarantee $80 billion to General Motors. They made a paltry investment in Tesla of $489 million. Google just put $1.5 billion into SpaceX. Apple Computer right now is sitting on $201 billion of cash. These people have more money than the United States government does. General Motors is wanting to rely on the fact that they're big. They haven't seen big. They don't have enough digits to be big in the way that the global internet has made, where you can manufacture something and sell hundreds of millions of them worldwide. You don't do that with plaid guys in coats on Texas tarmac out in the sun trying to sell cars with free Coke for the kiddies and balloon animals. This doesn't work anymore. I don't know how to get this across to you. We're going to go through a huge tsunami change. And the move from gas car to electric car is certainly part of that. But our whole economy worldwide is breaking into the technocrats and the others who work at Sunglass Hut for minimum wage. I'm not advocating this, I'm reporting it. And it's not in the future, it's already happening. Your media, your news media and stuff have failed you horribly in alerting you to this. This is why none of the leadership of our governments are aware of this. And it's happening every day and in plain sight. but nobody's talking about it because the media that builds our communal campfire have done such a miserable job of doing it and have become infotainment, regaling us with tales of shootings and cops abusing people and your rights and gay rights and the whole thing. They're missing the whole point. We have a mass migration of wealth toward technology and away from people working at jobs. Walmart is about to unveil some stuff you're not going to believe. There's not going to be any Walmartians in Walmart anymore. No old guys with carts. It's all going to be machines and technology. And this is the wave of what's going to happen to cars. Is not a conversion of General Motors, not a conversion of Fiat, not a conversion of Toyota. We're going to be converting those cars, the ones we like, as custom cars and show cars and heirloom cars and vintage cars. They're not going to be players in the future. BMW and VW have the tools to do this, but they won't do it because they're like the Burlington Northern Railroad. They're not going to get the aviation thing. It's not just about electric cars. The electric car is the nth part of it. Picture a whole new way of designing cars, manufacturing cars, delivering cars, servicing cars, selling cars, and buying cars. It's all different, and it's going to happen very quickly. Tesla needed to succeed, and then we need 2 or 3 others to come in, and then the gates will open, and there will be a lot of very innovative designs and new cars coming on the market. And once the dog is out of the box, you're not going to need billions to get into the electric car business. There'll be a lot of novelty vehicles and so forth. Let's take a look at one of them. If you will recall, I panned an Indiegogo crowdfunder that I said would never happen because the guy had raised over $5 million on a $500 electric bicycle that couldn't possibly be manufactured in that quantity by the 1st of May. And I was right, as always. He failed to do so. But you know, he didn't miss by as much as I would have thought, because in mid-July, one of our viewers, Bill, who has built a Ranger, an electric Ranger, got his Saunders electric bike. Let's take a look.
All right, so here's a quick walk around of my electric fat bike. Got about 4.5 inch wide tires, 26-inch rims. This is off of a crowd-funded website, Indiegogo. At the time it was $500, and I thought, what the heck? So I bought 2 of them, and wasn't really sure that any of them were going to show up, but it did, and here it is. And it turns out that it is really a fantastic thing to have. If you live in like a town or something where your commute to work is, say, less than 10 miles in one direction, this could really be the thing for you to save some money for traveling. And the cool thing about the electric bike is that with the electric assist, it makes it feel like you've got a constant tailwind when you're riding, so you really don't have to put much more effort into cycling this thing than you do, say, walking. So even on the hottest of days, you really don't sweat very much because you've got a good 10-mile-an-hour breeze blowing at you the whole time, so it keeps you cool, and you, like I say, you don't put any effort to ride it. So I'll show you what it looks like. So it's 36 volts. You just undo this little dealie here, and there you go. 36 volt, 8.8 amp hour, Panasonic battery pack, a little controller there, permanent magnet brushless DC motor back there in the hub. It's got gears in there, so the motor itself can be physically smaller with some gears. disc brakes, mechanical disc brakes. They work pretty well. There's a lot of rotating mass with these tires. It has a throttle right there with a little light so you can see what's going on. And you just push the pedal and there you go. And then also, whenever you crank the throttle or crank the cranks, it has an assist as well. So from the best I can tell, it gives you about 50% power when you're cranking the pedals. So it doesn't go the full speed that's capable of, which is around 20 miles an hour. I don't have a cycle computer on it, so I don't know exactly how fast it goes, but yeah. But it probably does about 10-12 miles an hour, just kind of cruising. We'll take it for a little ride, show you how it works. So the coolest thing I think about it is the noise that it makes whenever you cycle. It's probably a lot of wind noise right now, but turn around. Alright, so that kind of takes care of the walk around of the Sondor's electric bike crowdfunded campaign. It's probably one of the coolest bikes I've ever owned. It's not the highest quality. It's made in China, so some of the components are kind of chintzy, but value for $1, I'd say this is probably one of the best toys I've owned. So that about takes care of it.
Now let's compare that with Bill Green of EV World. He's liked electric bikes for a long time. Hadn't built much. He has taken this Bamboo Green bike, which has been available for $495, and a device that has an all-in-one battery controller, motor, and hub from Italy, and put it together. And he has a crowdfunder with a goal of $270,000. And after half the month, half the period that it'll be up, he's raised about $5,000, asking $1,975. And again, this goes to the value proposition. Here's a $500 special on a bike that's going to be $700. Here's a $1,975 version of a bike that I think is actually prettier. Is it 4 times prettier? Well, no. It's kind of like Azure Dynamics bankruptcy with their $58,750 offering of the E-Transit Connect that's available for $23,000 in an internal combustion version. It's like the Nissan Versa, which is $14,750, also available in an electric model called the Leaf at $26,000, which 3 years later is worth less than the Versa. Or the Chevy Cruze, which is now also available as a Volt, and $3,000 or $4,000 higher as a Cruze than the Versa, and they're netting $3,000 or $4,000 more after 3 years than the Leaf. Although they were introduced at $46,000. The adoption of electric cars among the general population has been less than satisfying. But part of it is a very simple reason. They're too expensive. And they're not too expensive because of the batteries. They're too expensive because they're not making enough of the parts. What to us looks like a lot of Chevy Volt chargers and a low price. I can get them from the dealers for $1,200. slap a controller on them, sell them to you for $17.95, fully functioning and ready to go into your build, which is $200 cheaper than our excellent Brusa charger, which is essentially an orphan. So it looks like mass production to us, but it really isn't. It's in minuscule numbers compared to the regular cars. And so it's not so much a lack of batteries as it is a lack of faith and a lack of mass production at prices that would be perceived as a value proposition. They raised $5 million, $500 at a time, for a $500 electric bike. A man who's been involved in the EV industry as a publisher for over a decade offers a similar electric bicycle at $1,975, and I doubt he'll raise $10,000 in the entire month. This is what's going on. If you're going to ask $100,000 for an electric car, you need to be like Elon Musk and it be a shit pot full of car. And so Faraday is going after that same thing. We're looking at $2 gasoline by December. That's what people are saying. Now, that's very curious, since all of this is a function of supply and demand. It will, of course, surprise you to learn that in June we used 9.6% more gasoline in the United States. 9.6% more gasoline in the United States than we did in June of 2014. All these people, chief oil analysts with oil price information services, everyone in the oil industry alludes to smoke, mirrors, and magic over the prices of things. There's no magic, there's manipulation. And it's being manipulated now, and it was being manipulated in 2008 for profits. It didn't need to be $4 a gallon then, and it can't quite be $2 a gallon now. This is nonsense. Don't fall for this. They're making it $2 a gallon because there's some very real fear over the inroads that less than 300,000 cars have made in a world market of $85 billion a year. It's preposterous, but that's what's happening. And they spin it every way they can do it. It's total bullshit. Toyota has issued an ECU, engine control unit recall, about 625,000 vehicles. 109,000 examples are the 2012-2014 Prius 5. Now, the only reason I bring that up is 625,000 vehicles. I wonder what they pay a dealer to reflash this ECU. Would it be $100 or $200? What would a dealer want for that? $300 times 625,000? Where what you see with the Tesla Model S and probably the Faraday is a little advisory that comes up on your screen. Your software has been upgraded. Do you accept? And in that vein, we have been battling and continue to battle on right to repair. And right now, the federal agency charged with protecting American motorists wants to know more about how hackers remotely commandeered and controlled a Jeep Cherokee hours after Fiat Chrysler recalled 1.4 million cars affected by a flaw in their cellular connections. And several congressmen, Richard Blumenthal, Democratic Connecticut, cyber threats in cars are real and urgent, no figment of the imagination, as this huge recall demonstrates, says Senator Richard Blumenthal. Incredibly, Chrysler delayed disclosing this chilling cybersecurity danger egregiously and inexcusably, and strong sanctions are appropriate to send a message that other auto manufacturers will heed. So it appears Chrysler is in deep trouble, doesn't it? Blumenthal and Markey introduced legislation Tuesday that would set minimum standards for automotive software security and create a system that would help car shoppers to be more knowledgeable about security in particular vehicles. A report by Markey's office concluded only 2 of 16 automakers could respond to a real-time infiltration. And the story was broke in Wired magazine. So shouldn't we be alarmed? There's no clean game in the game. This month, the Copyright Office is issuing a waiver to the DMCA that specifically allows you to access the software and the CAN message trafficking without violating the DMCA. And so wouldn't it be handy for this story to break about these wanton hackers breaking into a Jeep Cherokee while it's going down the road and posing a real and serious threat to the driver's safety in St. Louis, Missouri? Wouldn't you find that alarming? Shouldn't something be done about that? Oh, but wait. No one mentioned that the hackers were being paid by Chrysler? And the entire thing was staged for Wired magazine? And the recall was timed so that they could then assure motorists that they were not subject to this? And Markey and Blumenthal are on the payroll. The whole thing is a scam designed and timed to coincide with the Copyright Office ruling on essentially right to repair. The entire thing is just bogus as hell. Let's take a look at our valiant efforts at hacking and causing all kinds of mayhem that Wired magazine probably won't be very interested in because it doesn't really do any of that. Let's go to the Tesla test bench. I got some stuff to show you. Okay, we're here with the Tesla test bench. We several weeks ago, the EVTV hack team was here and we celebrated the turning of the motor. We announced it. There was another announcement of a Tesla drive unit hack of the following day by Michael Elias. And we've since been working on mostly our tools, SavvyCAN, and the generalized vehicle reverse engineering tool, which I have hooked up 2 of them to the bus right now. And this one I'm going to send with. This I record with. And this JLD 505 underneath is actually measuring voltage and current and RPM and injecting 2 messages, a 404 and a 505, into the stream so we have some sensor data. There have been quite a bit of online comment, and I guess we have a long way to go in getting the community up to speed on controller area network. That's where a lot of EVTV effort is going to go over the next year, and probably for the foreseeable future. And there's a reason, I believe, that the use of OEM EV manufacturers' parts are going to play a large role in custom electric vehicles that we do in primarily conversions. Why do I think that? They make a lot of them, and so they're relatively inexpensive compared to the very one-off specialty items that we've used and EVTV has sold in the past. They're ubiquitous. If your Chevy Volt Charger in your Studebaker burns out, or if you burn it out, hooking it up backwards, you don't really have to come back to EVTV. You've got the controller and from us, and you can go to Mr. Goodwrench at the GM dealer in your area and give him the part number and just get another charger. And so worldwide kind of dealer support for parts if we use the parts used by worldwide car companies. But the comments about the two hacks of the Tesla drive unit were somewhat discouraging, not in their nature, but in the lack of context and data. Clearly, we've got a knowledge gap to fill, and that's probably a good thing for me and a good thing for EVTV. Michael Elias turned a drive unit actually out of a Daimler Model B electric, which is a Tesla drive unit. It's not exactly like the one in the Tesla Model S, and there are some curious differences. However, he did turn it, but he used a hardware controller board hooked up to it and turned it at about 10 RPM. He didn't really do this to offer a solution for using Tesla drive units. He was trying to gain some attention for his controller board. And I've been talking to Michael for 6 months about this controller board. Still don't have one, but it has some remarkable claims that appear to be plausible. And the biggest one is that you can, it self-tunes to almost any kind of AC motor. Normally, you have to match your controller and inverter to the motor. In other words, a leaf inverter will only work with a leaf AC motor. And this has been a characteristic of AC drivetrains. Our UQM inverter will only work with a UQM motor. Our DMOT 645 will only work with a Siemens motor. Michael's claim is that he has a universal controller that, number one, can use any power switching electronics. That's the IGBTs and caps, snubbers, and so forth, that actually switch the high current. This is the controller board that actually causes them to switch, that drives them. And his claim is that he can train it to work with any motor. In fact, it has some modes where it runs through a couple exercises and trains itself to drive that motor. That's actually a function of software, and it's a very interesting function if he's pulled it off. We're very interested in it. As a solution to drive the Tesla drive unit, it makes no sense at all. The Tesla drive unit already has a perfectly good controller board in it. If you want to adapt that, he would have to shrink the size of his controller, and then you have to take the can off, mount that in there, and make about 2 dozen connections to the encoder, to the gate drivers for the power electronics, and of course, again, to your 6 wires from your throttle, 2 from the brake, a charger interlock, and so forth. Once you get all that done, you still have to drive his controller with CAN messages. The difference is he can, in software, knows what those CAN messages are and what they do and can publish them. And so that makes it pretty easy to interface to it over the network, but difficult in a hardware sense. And to me, it makes no sense at all. The Tesla drive unit is quite well designed, and in fact, I'm finding my admiration for it growing by the moment. On the other hand, I have seen it written that all we did was capture some data traffic and play it over the CAN bus network and make the motor spin. Actually, that is all we did. They're quite technically correct. Clearly, they don't get the import of what that means or what that is, or they see it very differently than I do. Once we've done that, we've kind of proven the drive unit runs without the car. We just need the messages. At that point, we've got it down really to a matter of software and decoding the messages. And everything I've aimed the EVTV hack team at, that's fallen actually with kind of awe-inspiring speed. This turns out to not be any different. In the probably 6 weeks since then, we've spent most of our time going back and reworking Colin's SavvyCAN application that runs on the laptops. Also some work on the generalized vehicle reverse engineering tool, which resides in our little CAN DUIs, and in one case over here, one of the new EVTV DUI boards that has a CAN port on it. I've done some work with the JLD 505 and the software to gather some sensor data. So we're not really working on the drivetrain, we're getting ready to work on the drivetrain. This week and last week, really, we have been actually then applying that to the task of how to gain control of the drivetrain. See, if we can gain control of the CAN messages, decode what they mean, we can skip all that hardware stuff and simply make a device to control it. Now, you still have to have that with Michael's board. We're kind of also doing some getting ready in that respect. The generalized electric vehicle control unit normally converts throttle values to CAN messages to drive the inverters and the motors. In this case, we don't need that, actually. It's kind of a peculiar case and going a little bit old school. The throttle on the Tesla drive unit is a 6-wire unit with 2 signal outputs that's wired directly into the inverter in the wiring harness. It also has 2 wires for the brake, one that's 12 volts and one that's an open. And when you press on the brake, those invert. And the 12 volt becomes an open, and the open becomes 12 volt. And that's a very secure signal that you have a brake on. And so that's how we're going to drive the unit. CAN then becomes a function of mode and kind of some timing functions. And it's really a way the inverter reports the various statuses to the vehicle, like RPM, voltage, current, torque, and so forth. So either way, with Michael Elias's, or directly as we do it, we're going to have to interface with that inverter using CAN. What I've selected, and I could be beaten out on this, is something we already carry in the store, and it works with the JevQ now, or the Orion BMS, or with the High Performance Electric Vehicle Systems AC line of actually the Curtis controllers and software they have in that. This is called an electric vehicle interface, an EVIC, and it's produced by Brian Gallagher at Andromeda Interfaces. This actually does CAN, but it also has Ethernet ports, USB ports, but it's on a board that has a Freescale 100 megahertz microcontroller that's actually quite beyond anything an Arduino can do. And of course, it has to do quite a bit to handle the touch screen and the display for the unit. But it also does CAN. Our issue is we have to control this thing with regards to mode. When you're in park or reverse or drive or neutral, whether you have regen on or off or high or low, whether you use creep or you don't use creep, there's actually two levels of aggressiveness in the inverter that are determined by a range mode and a standard mode. And so we have some mode indications. We will have data from the inverter, as we do from all inverters, having to do with RPM, torque, and so forth, that we would normally want to display on an EVIC display anyway. And so what we're going to add is essentially buttons and sliders, very similar to what's in the Tesla Model S, but on a much smaller screen. We don't need 17 inches to put it in park or to select creep mode on. But we do need some way to enter it, and I think this is the way. We use this with a JevQ, but in this case, the whole purpose of the JevQ is a little bit obviated by the fact that our throttle goes directly into the inverter. So I'm going to try to jump skip this and use this for everything. Mr. Gallagher at Andromeda Interfaces has been most generous in allowing us to license their software development kit kind of at an early stage before they're really ready to support that or able to support that very well. In fact, I sent him a laptop. He's installing their SDK for me. I'm going to have to go through a little bit of a learning curve to get up to speed in C#, but it's basically C++ with some network sugar and syntactic sugar for networking. So I don't have a great deal of fear of it. And we're going to try to develop a kind of compatible system to what Brian's already doing. In fact, some of the screens are going to be the same that show RPM and current and so forth. But then you'll have buttons or another screen with buttons where you actually control the Tesla Model S drive unit. I mean, you could do that with Michael's board. And my point is, we don't need the board. The drive unit already has a control board. All we have to do is determine the CAN messaging. And that's not the hill that you would imagine. I fear that there's a lot of, I know there's a lot of Tesla awe out there, fear and awe, and there seems to be in our viewership fear and awe of CAN itself. And it's not that big a deal, guys. And I know a lot of you. A good part of our viewership really didn't come from the car community. They came from the IT community, the internet, networking, and so forth anyway. So it's same old thing. It's not even TCP/IP. It's more like RS-232 modem communications. And such old hat for many of us that it's simply not a big issue. It is a new issue, and what we find, alarmingly, is that the good tools to deal with it are extremely pricey. And that's because there's 100 guys in the country using them. We're developing our own. They're going to be pricey too, and for the same reason. But we hope to expand the number of people, and it'll be at a different scale. Instead of 5,000, we're going to be talking 500. Instead of 3,000, we're going to be talking 300. So an order of magnitude lower cost and generally easier use. Instead of piling 300 features into one program, we'll kind of have it broken up into what you need for various things. So what kind of progress have we made? We did a lot of captures on the car. My wife has kind of given up the car for the last month. going from park to drive, and drive to reverse, and reverse to neutral, and turning creep on and creep off. We did a heavy acceleration across the bridge, drive around the circle, and captured these into data files. Obviously, the most useful to start out with would be you're parked and you put it in drive and drive away. And so we did that. Now, the inverter also puts out messages. There's no point in us transmitting inverter messages that we recorded in the car back to the inverter who's trying to put out the same messages. That's just going to confuse things. So we've written a couple little stripper files that will strip those out. But Colin has set up a thing called playback in SavvyCam, where I can load one of these files and play it back out over the bus. But more importantly, it lists all the messages by message ID, and I can put a checkbox next to them as to whether we're going to transmit those or not. And of course, I can transmit on either the buses at varying speeds, which does seem to be important. And so that's how we do this. We stripped out all of the inverter messages, took all the car messages, and started deleting them. Meanwhile, on this machine, we record the JLD 505 messages, the inverter messages, and the messages I'm transmitting, and that kind of puts it all back together into one big stream again. But now we have known sensor data that is time contextual with what we're seeing in the file. In other words, we know what our messages have in them, voltage and current and power, motor RPM, gear RPM, speed, and so forth. Tried to get temperatures in there, and I just kind of failed. When I would add that Dallas one wire, it would just kill the little processor that Paulo had in the JLD 505. So we left that out. So this is our playback machine, and this is our recording machine. Here's our control panel for the unit. There were 23 messages that are unique to the inverter and provide various data. We have about 2 of those decoded, but they're kind of interesting. One of them is RPM, and one of them is torque, and 3 of them seem to be different scalings of either torque or current, and sometimes it can be difficult to discern between the 2 of those. That's not much about controlling the motor. We're going to decode those as we can one at a time, again, comparing it with sensor data that we do. The more exciting part is, of course, to get the thing to run. The car, when we're driving it, carried 164 different messages. And so we could play those and get the drive unit to turn. But would you believe the drive unit really didn't care about some of them? When the car was communicating with the battery management system or with the temperature of the batteries or the, let's see, what else is in the drivetrain bus. There's actually 6 buses on the Tesla. The drivetrain bus is the one we're interested in. The DC to DC converters on there. And of course, that drivetrain bus then interfaces with the central controller behind your 17-inch screen. Of the 164 messages, we turned them off in various blocks and combinations, and literally in a day determined that there were precisely 7 messages required to control the Tesla drive unit. And so I've got those 7 messages here checked, and we're going to transmit just those and do this on a file that purports to go forward. Now again, to move from park to drive, which is the file we're doing, we have to have the brake on. This is in the car. In the car, if you don't put your foot on the brake, you can't change from park to drive. So we know this. So I've got a button here that I can press, and that drives a relay that simply switches those two 12-volt inputs to simulate the brake. I'm going to turn on my cooling and my 400-volt battery here. Do a little pre-charge on that. I'm seeing 387 volts at the moment. And then turn on the high voltage positive. And here's my inverter. And I can see I'm doing about 570 frames per second into my recorder on the right-hand machine. And here I've got my Christmas tree lit up. I'm ready to go. Got the inverter on, and I'm going to press the brake and turn on my file. And I'm going to run that a couple thousand things, and we start to turn. Actually, we're operating the thing quite smoothly, and that's because it seems to run a lot better with all those other trash messages out of the way. So we're actually creeping forward, and that is creep mode, and we're drawing 0.7 amperes at 385 volts, so 2,500 to 3,000 watts, which is about what you would have to creep forward. Interestingly, I have extremely good control, very smooth control with the throttle of the drive unit, and if I back off, I get regenerative braking. Since I don't have much of a load, much inertia, I don't have much. I don't have a car going forward, but I can actually watch the current go from a minus 0.7, let's run it up a little bit, and then come off, and I peaked at 52 amps there of regenerative braking, and so we have very good control of it. And we're going to loop that file in those 7 messages and just transmit them continuously, and we can run this as long as we want and forever. We can also shut it off and bring it back on and run it. Recall there was some concern about a serialized version. We actually had some not very reliable information from someone who salvages these, that if you take one drive motor and put it in a different car, that you can drive it once and then it goes into kind of a limp mode, and then you have to reset the whole system by disconnecting the battery to get it back up. I can simulate that here by simply letting the file run out, and then it'll free spin. I can drive it. I don't have any regen, and then when it finally spins down and I quit, then it won't do anything. We don't have to worry about that. That serial number exchange kind of qualifies whether the car sends the data needed to drive the drive unit. Obviously, the car I own has the right serial number, and so it sends the right data. And the serial number data isn't part of it. It isn't anything that's needed by the inverter or the drive unit to run. So we've peeled all that away and gotten down to 7 messages that it does need to run. The system is limited to 16,000 RPM, motor RPM, and that corresponds about, in my case, to 134 miles an hour. And as you can see, as it comes down, there's kind of a progressive level of regenerative braking. So you don't have the same level of regen at 130 mile an hour that you do at 7, but that's a good thing. And that's all accounted for in those 7 bytes. So that's the process. We're down to 7 bytes to control it. We've already found the byte that turns creep on and off, and we found the bits in a particular message that sets the park, neutral, drive, and reverse. And that's actually the most important information in the whole thing. Once we can set that and run a few heartbeats into the inverter that it needs for timing, we're kind of near enough done. We can put this in a car and drive it now, and it'll work fine. I can put it in park, I can put it in reverse, I can put it in drive, put it in neutral, turn creep on and off. I have not yet decoded the 2 levels of regenerative braking, and I'm hoping to decode that not only well enough to do that, but I think what I'll find is that there might be a way to actually vary the level of regenerative braking to whim. Since, if you notice, it did vary from the 138 miles an hour down to 0, and we can also set 2 levels. I have to believe it's some numbers in some bytes in one of the messages, and so we'll be able to do that. What else do we have? This range, a range mode and standard mode is interesting because it might be the same. We may be able to tune this to various levels of power. Apparently, the Tesla can, and get different levels of power out of the motor at whim. They have it set to where you won't tear up their motor. Well, we're kind of hot rodders. We might want a little hotter motor than Tesla quite puts in their car. And that would be available to us. So it's not really a blind playing of recordings. That's a step in the process to learn how these messages work. And we don't have really a week or 10 days actually doing that level of analysis because we've been working on the tools we needed to do this effectively on this particular thing. Colin's worked on SavvyCAN. I think SavvyCAN is going to wind up being the CAN tool for automotive use across the board before it's over. He's taking the good and the necessary from a $10,000 system and duplicating it for a few $100s. Similarly, we're using Arduino style boards to actually do the CAN. Since we don't have the Arduino volumes, they're not going to be $35 a piece. But they're going to be very reasonably or popularly priced where anyone can play. And so this CAN is not precisely magic, but we're not precisely idiots playing tape recordings into the motors. The people that are commenting on this are kind of in the state of don't know and don't know they don't know what they don't know. We're exploring new areas and learning things, but we kind of have a pretty good idea what we're going to find. And right now I've got extremely good control of the motor regenerative braking, creep. I can put it in forward, reverse, neutral, and it's instead of the jerky and kind of times alarming operation we had before, I've got very smooth, very good control of this motor and inverter as it sits right now. So I couldn't be happier. We're running this on the bench at a level that would work in a car, and we're just getting started. I think we'll get a lot of neat and interesting information from the 23 messages from the inverter, and there's further analysis and tricks that might be gleaned in analyzing these 7 messages that actually control the drive unit. Some of it's been kind of surprising. The modes, park, reverse, neutral, and drive, for example, I would expect to be a standing state machine where you just had some bits that the car and the inverter agree on, that when this is up, this flag is up, this bit is 1, you're in park. And when you go out of park, it goes off. And if you go into drive, that one comes on. And where at every message, you could check at any time and see how it works, what state you were in. That's not the case. The state machine is held in the inverter, and the car sends it about an 18 frame signal, signaling it to go into park. It doesn't mention anything about where it's at. It doesn't care where it's at, apparently. It wants it to go into park. Similarly, there is a different bit that flashes again for 18 to 20 frames to set it to put it in drive. Doesn't care what it's in. It doesn't know what it's in. It's just telling it to go into drive. The inverter makes the decision whether it should do that or not, based largely on whether it has a brake input or whether it's going 130 miles an hour. If you were going 130 miles an hour and did have the brake on, it's probably still not going to go into reverse, that being the nature of software. And so a lot of the intelligence is in the inverter. It's kind of old school in that the brake and throttle are direct entries by hardwire. And we're left with the control of it being a modal. What mode are you in? And what features do you have turned on? Things you can turn off and on from the touchscreen is what we're communicating back and forth with the inverter. Things like power usage and current usage, the things you see displayed on the car that's logged, how many watt hours you've used for the last few miles, is obviously coming from data from the inverter. So it's actually a pretty simple system with some sort of non-standard and kind of interesting thinking to me. It's not the way I would do it, but it's nonetheless effective and interesting the way they have done it. And so we're having a ball decoding that, learning how to work it. This is no thing. This will be done in weeks or months. Again, I've got it planned out to EVCON and beyond, and it could be the end of August. We're putting it in a car. So I think this is the way to do it. You take an off-the-shelf drive unit, you plug a EVIC into it with a wire harness and a throttle, and we're done. We've got the connectors, we can make up the wire harnesses, and soon we should have software in a single display that's also a microcontroller that can do CAN, and as I said, kind of a more capable one than we use. It's a free scale 100 megahertz microcontroller that's really very capable and used to doing heavy duty work like displays. It does have Windows CE as the operating system. I'm a little concerned with that. But if it can do the CAN data at the pace we need to do it at, it can certainly do the logic. I mean, we're not going to put it into park at 130 either. It's just not allowed. And we'll have those kind of rules built into the software in this thing, and probably run wiring to where we're aware of the brake condition as well, although I imagine that'll be reported by the inverter. And so that sort of thing. But it should wind up being a fairly neat little device. The EVIC, a throttle, a wiring harness, and some instructions how to wire your brake into the thing, maybe some outputs to your reverse lights, to your brake lights, so that when we're doing regen, it'll turn on your brake lights. Some things we do in JevQ as housekeeping, we would also do in this, but it's 68 amps, not bad. And so again, we're kind of celebrating it. The device is, I guess, 310 kilowatts. It does 601 Newton meters of torque. That's about 443 foot-pounds. It'll do 16,000 RPM on the motor side. Basically 446 horsepower at 5,000 RPM on the motor. And so it's just a monster, 3 times the power and so forth of anything we've handled here at EVTV. But with a single speed gearbox that's fairly deluxe and does a 4,600 pound Tesla Model S at 0 to 138 miles an hour. I think it'll work just fine. Some challenges perhaps in mounting it in a car, but that's always a challenge for me because I don't really understand mechanical things. With a TIG torch and some metal, it can be done. You kind of want to have it lined up straight. I'd like to get the whole clip out of the back end of a Tesla, and we may have to buy a wreck or something to do that, just to see how it's put together. Because with that kind of stuff, you want that kind of power, you want it to be pretty stiff. Tesla, for example, has announced an upgrade in software for the D model to, I think, from 1,200 to 1,500 amps into the same motor, same inverter as a software change. Conceivably, we could award ourselves the same increase through these CAN messages. And so this could be a very violently powerful drive unit. I had expected to see a flood of them by now. I see salvage cars going all the time. I don't know what they're doing with the pieces. I do not see the drive units on the market. I've got 2 of them. I'm sure we will by this time next year. We should have plenty of them. But right now they're fairly rare. And so...
Hi, I'm sorry to interrupt your show. I'm Jen Rickard. I'm Jack's daughter. It's his birthday today, so we're going to take off with him and have a party. You ready?
Sure.
You can open your present if you want to. I got something for you.
What do you got?
Well, it's something that you seem to be very extremely, excited about these days. Where's your bug zapper?
Superman Dad.
Yeah.
Yes, I'm a bug assault freak. Well, let's take a look here. We're going to have a party if I'll just quit working and go do that?
Yeah, if I could steal your wife from your viewers for a brief moment. We have stuff going on. Now, I was a little disappointed because I had purchased this thing for you. Mm-hmm. And then I come to Sunday dinner.
And I had one?
Behold, the man who already has everything went and got himself one of these too.
It's hard to buy for a guy who likes gadgets and just buys them.
I saw it and I was all like, yeah, that's really cool.
What do we have here? Ah! More bug swatting.
More bug swatting, yes.
The Executioner. Mm-hmm. This is the thing. Mm-hmm. An electric bug zapper that you play like tennis. Mm-hmm. I'm on board. Yep. We're doing some other stuff with a device called a bug assault. More on that in a moment. Stay with us. Cool.
All right, you ready?
I love this stuff.
Good, because we're having a theme party for you.
Okay.
And it's called Death to Bugs.
Death to Bugs? Well, I better bring my gun.
And you should bring your gun and any other gun that you might have because there's a pig down there that we roasted.
You're kidding.
No, I'm not joking.
You roasted a pig?
Well, we did it the Hawaiian style because on short notice, apparently it's really hard to get a rotisserie.
Around here, probably, yeah.
As our world grows, it's necessary to invest in sustainable transportation to reduce our impact on the planet and ultimately create economic efficiencies wherever possible. Electric vehicles are becoming the leaders of this efficient, sustainable movement. In electric vehicles, the driver experience is just as important as the batteries that power it. EVs display different information than conventional vehicles, such as the amount of energy stored, expected mileage on a current charge, and distance until empty. Monitoring vehicle efficiency and energy consumption are more critical than ever because of driving range limitations experienced in EVs that are different than your conventional vehicles. This presents new challenges to structure and simplify new driver information for operating EVs. Andromeda Interface's EVIC was designed to collect, interpret, and consolidate data onto one vehicle dashboard to provide a reliable and configurable device to monitor the operation and safety of your electric vehicle. From monitoring your motor controllers to your battery management systems, EVIC is a human-machine interface that seamlessly interprets all the complex data coming from these devices. EVIC presents the driver information in one simple display unit, and we are continuing to build our portfolio of certified interfaces from other EV suppliers. Please review our list of supported EV components on our website. Andromeda Interfaces is striving to enable human-machine technology that helps improve the safety and efficiency of electric vehicles. By doing this in a cost-effective way, we are helping to accelerate the growth of sustainable transportation.
And so that's how that comes out. We've already located the message that contains most of the mode commands we're concerned with. There is some kind of clocking, kind of a security sequence that's in there, or a validation sequence. We've already sourced that out and have done software to reproduce it. I have Monday going to receive my new Dell laptop with Visual Studio 8 and my SDK from Andromeda Interface. We, of course, carry their EVIC 7-inch touchscreen display that we're going to have working with the JevQ. In fact, I've got the software for that done, and it works very well. We also carry it to work with the high-performance electric vehicle systems line of motors, and it does that very well. But I have kind of selected it, and because of the generosity of the Andromeda guys, they have licensed their SDK to me to write software. They're actually going to help me get up and running writing software for their, they call it ADM Milky, which is this hardware. It has a Freescale 100 megahertz processor in it. Runs Windows CE. They develop in Windows Visual Studio C#. None of that would be my selection, but they designed the stuff. I think it'll make an excellent controller for the Tesla. And with this and a throttle, maybe a relay off of your master cylinder braking, and a wire harness, which we'll probably have developed professionally with the right connectors and so forth. We should be able to, before the end of the year, offer a controller to control Tesla drive units, much as we control the Volt charger and the Delphi DC to DC converter and the Volt DC to DC converter. And one by one, we're going to knock off all of the desirable parts of OEMs out there so that you can incorporate them in your car. I received this week the first batch of 100 Candui Tuis. Actually, we call this the Teodora after Paulo Alameda's mother, who's named Teodora. And this is a shield. We had a Candui shield. This is our version 2. We removed the DB9 and went to all terminal screw terminals. They're a little smaller than the ones we've been using. I gotta say I like the bigger ones better, but we had a lot. This was pretty busy to put on there. We also have a switch to do the can termination, which is much easier than soldering the pads. And the big pain in the schwanz was to put these long pin stackable headers on it, where you can put this on an Arduino DUI and then stack other shields on top of it to add things like GSM or whatever. But this will give you 2 CAN ports or a single wire CAN port. We also have an analog circuit to do NTC thermistors to get a single temperature reading, like from the Ebbensbacher, and your 12 volts. Again, it has an SD card thing, so we've got those in, and they'll be up on the website in no time. Forgot about Tesla. In addition to their improvements to their car, there are some serious reports, and I'm very pleased to report serious reports of drastic reductions in repair part prices. One authorized Tesla repair center, and that's mostly for body work and so forth, gave an example of a part that had been $1,200 that's now about $350. This they first talked about at $2,500, and we've received ours this week at $450. They are available, and it is the Tesla CHAdeMO adapter. And you plug your CHAdeMO connector into here, and this part, of course, goes into the car, and we can charge the car. And instead of $2,500 that it was unobtainium at, they are now actually obtainium and at $450. And so Tesla's making a number of very user-friendly moves there. We have a video from Nick Smith in New Zealand, and he has finally updated us a little bit on the Miata. Last week, he showed us his instrument panel and how that was going. I have to tell you, this is David Seabury's little box. It's in a NEMA enclosure, but it's a tidy bit of wires and a USB port. And he has several boards in here that make it kind of complicated, but it's not complicated to use. It basically takes CAN commands, and you can pretty much make that be however you want. He's got a nice menu system that lets you scale those CAN commands into one tachometer output that does not stop in the magic places Nick showed you 2 weeks ago. And in fact, David's going to contact him and offer to help him with that, so that's not quite the same problem. It'll do 3 of the gauges, like Nick showed you, and I think 2 idiot lights it'll run, and all that CAN control. And we have that in the store, and no real takers, but it's a marvelous device. This week, Nick attacks his vacuum system for braking. Let's take a look.
So what's funny about any project is you never really know which part of it's going to cause you the most trouble. And while I thought that the sway bar was going to be my biggest problem, what's turned out to be the biggest problem was actually the power steering pump. So I've driven a few MX-5s that have been converted recently, all actually with the AC50 motor. And these cars have one thing in common, and that is that they've had depowered racks. And I find that a little bit heavy, and the manual racks are a little bit hard to come by here in New Zealand. So I decided to go with the good old Series 1 MR2 power steering pump. I've had this hanging around for several years while I collected all my parts, but I've elected to install this in the car, and I thought a nice place for that would be up underneath the wheel arch. And after talking with people like Tim Catalier in particular, I decided to try and vibration isolate the pump, because I've seen YouTube videos and these things sound like they're absolutely screaming. So version 1 was a bit of a mount bracket with some rubber isolating bushes and a bit of a cradle on the motor itself, and there we go, such like. First problem with that was that the counterweight tended to want to twist the pump over. So I then thought about similar to this, putting a little pin in the top, and so we could sort of mount this through a bushing, and that would stop that from pivoting over. So that turned out to be not very successful either. So after a little bit of cutting and hacking and chopping things about, I've decided to actually hard mount it and see how we go with that. So if I spend any more time on this, I'm going to go crazy, so let's just get the thing in the car. One of the first things I did actually was to replace the existing stem bolt fitting here with an AN6 hydraulic fitting, and we should be able to call in the mobile hydraulics man and get some hoses wired up for the car up here in my garage at home. One of the other things is I managed to procure the original plugs and pins when I purchased this, so I've been able to rewire the mating side of this plug with some high voltage cabling, or high current cabling I should say. This is obviously a 12 volt pump, and that will fit onto a fairly juicy 60 amp 12 volt fuse, which I'll mount up on the firewall probably. I think I've actually covered it before, but I'm going to probably power this directly from the cable that goes to the battery, which was originally connected to the starter motor. So let's see where it's going to go in the car.
Okay, so this is the passenger side wheel arch, front wheel arch, which is where I'd always intended that I would like to try and to fit the power steering pump. I was going to try and mount that bracket I showed you just previously up on this area through here, up on the front chassis. Unfortunately, there's a few holes already in it, but none quite where I was looking to mount it. We have an issue here, so we've got the front spotlight that gets in my way, and also the routing of the hoses back through from the power steering reservoir on the other side of the wheel arch there. So after trials and tribulations with the vibration isolation style mount, I thought, well, we've got a fairly handy M6 stud there, and another hole a little bit further back here, an M6 as it turns out to be, there. So I thought, well, bugger it, there's too much hassle so far, let's just hard mount it. So I'll chuck the pump up in place and show you what it looks like. And there we go. I think we should be okay for a first try. My bracket's been a bit hacked up a bit, so I'll get a new one made up to all the proper dimensions. As you see, I'm not actually picking up that front hole yet, so get some spacers made and all the right bolts and etc. But so we've got the hydraulic inlet pointing in the, oh, sorry, that's the outlet, high pressure outlet, pointing in the right sort of direction off towards the power steering rack, and our return line up there behind it, so we should be able to wrap things around from inside the engine bay like so. So you can see that there in the front.
So right now I've got the power steering pump sort of temporarily hooked up electrically. I'm using the what used to be the alternator lead to provide the power, and it's going up to the relay block there, and I've got a high voltage relay or high current relay down there to power the power steering. At the moment I got the battery charger on for the 12 volt and we're reading about 12 amps going into the battery at the moment, just topping up the 12 volt system. So up here on the dash we have the finally installed JLD 404 and the isolation switches for the heating and the power steering. Now this at the moment is hooked directly up to power, so normally it'll only work on the key switch, but at the moment it's working full time. So that means I can turn the power steering on, and it's making quite a racket. I don't think it'll be quite so bad once the bonnet's on, but we are drawing about 35 amps up from 12, so that means about 20 amps draw on the power steering. So if we just hold that there for a minute and crank the steering wheel around a bit, it's topping right out. It's topping right out at 50 amps plus there. So I've unlocked the steering wheel. Forgot to put the key in. Okay, so I've just unlocked the steering. Let's have another try. Amps plus. Okay, I think that's enough fun for there. Okay, so now with the key switch on, you can see the isolation switch is illuminated. Turn it off, off she goes. And that just then was the vacuum pump. So we've also got the vacuum pump hooked up to the same 12 volt supply. And tracing this back, we go to an automotive relay. This fuse box is actually out of a Mitsubishi Galant, but by the time I'm finished, that's going to look quite at home here in the car, I hope. So we've got a nice cover go on there, and we'll mount up the main isolation fuse for the power steering. I've got the inertia switch wired up there as well, and a couple of relays to go in to provide extra 12 volt power for the controllers and the vacuum pump and a few other bits and pieces, and the front negative contactors. So here's the vacuum pump, all mounted up underneath the battery box there, and that runs off through a couple of hose cables. And I've got a vacuum reservoir hidden down the front. So we're starting to make some serious progress, and we'll carry on. I've finally made it back to the workshop, and once again Pukekohe Park's got a bit of racing going on in the background, so try and tune out that horrible noise of petrol engines roaring. And what I'm working on today is the throttle, and you can see I've just mounted off at the back there an industrial micro switch similar to this one, or in fact the same, standard sort of thing, normally open, normally closed contacts. And I'm using the original MX5 throttle body, as you can see here. I've mounted a little bolt up on the original butterfly there, and that the head of that's pressing on the plunger of the micro switch on the other side. So that works beautifully. Got a little bit of over travel there, and that's great. So the original MX5 throttle pedal or throttle pot there corresponds to a Type 3 from HPVS schematics. Little bit of figuring out which pin was which, but I think I've got that down now. And all I have to do now is to connect the wires to the micro switch. Got the original tail off the MX5 wiring loom, and well, currently a 3-pin, but I'm going to have to swap that out for a 5-pin or a 6-pin Deutsch connector, and patch that into the loom supplied by HPVS. Yeah, so stay with me. I'll carry on and wire that off.
Again, Nick, you're straining at gnats here. Good work, but if you were only a little closer, this is our kit. I don't like vacuum systems, and I don't like putting them in electric cars to get braking and steering, but a number of cars did not consult me when they were designed 20 years ago, and so that's kind of what you have to do. We've got a kit with kind of a fancy tank. It's a small one. You may want a larger one, and you can adapt that. A switch that turns on the pump when it gets down, a check valve, a relay, some hose, some wiring with a fuse, some brackets even, but the heart of it is after some searching, and one of the reasons I detest vacuum pumps is because they're so loud. I have rigged up a little bamboo battery here, 12 volt, and that is what our pump sounds like. It's a very capable pump and very quiet. If we have a problem here, it's probably too small a tank. And in fact, they have used this and were complaining about it coming on too much over in Sparta, Michigan, where Colin Kidder, our own programmer, continues to work with a family business and on a conversion of a 1959 Mercedes SL190. And they were complaining a bit about the thing running too much. The answer, of course, is a larger reservoir. It kind of depends on what kind of car you have and how much vacuum it takes. This is more than adequate for many modern cars. Probably needs a little bit more on a 59 Mercedes-Benz. And what that looks like is just a bigger tank. You can make one out of PVC pipe. This really has no magic to it. We simply route. The whole trick is the pump and the check valve and the switch that comes on to turn the pump on when the pressure gets too low. And so that's that. And let's take a look at Colin Kidder and the SL190 progress this week.
Obviously you can see we're outside. Been doing some test driving. I don't know how I had a brain malfunction here when I put this battery out here. We're going to move the battery up into here because when the hood opens it swings down in too close to that battery and that's not good. So I forgot about how far the thing swings, so we're going to, cables are long enough, but I'll build a bracket to mount the battery back in here. I have a bracket made. To mount this temporarily. It's just sitting up here. This is the vacuum pump that makes the brakes operate properly. I guess I'll have you back out of the driveway and then accelerate away so I can see what we have here. Wait till this truck goes by.
It's still a little messed up.
The taillight on this side, when they assemble the new taillights, they glue them in with sealant. And the sealant came loose and the taillight fell off. So we have it. We'll fix it back up. Pull back out and get straight, and then I want you to pretty much punch it right to the floor and see how fast it'll take off. Go for it. He's doing about 50 right now. Wow, he's hauling butt. I would have to say that it's faster acceleration than we had before. He's already up the hill, turning around at the top of the hill up there. I got zoom. Let me see if I can bring it in on him. I can't hardly. I think it's recording now.
Just a moment here and I'll record on this too. Good.
We're gonna see how it goes.
All right, now
You're recording?
Yep.
Gauges aren't operating. Doing about 40, but I didn't accelerate super hard. On this private road here, traffic is very limited, but I don't need somebody pulling out in front of us. And I got a squeak somewhere in the suspension. I know there's wires hanging out everywhere, and we're tweaking that now too. I'm not sure he's even got the turn signals wired up yet. We're gonna hit traffic here out on the street. See if we can somewhat keep up with them by the time we hit. Now we may end up blowing some paper off. Probably going to be an awful lot of wind noise. I'm catching this traffic like mad. car was before, old mackerel, it just has some, it almost doesn't want to quit accelerating. I couldn't go to its potential without hitting vehicles, so I would say I was at 80 miles an hour in no time at all, and I'm gonna back off here, let that truck get ahead of me. That truck is almost a quarter mile ahead. Now I'll mash this down. There's no traffic between me and that truck. The truck's about a quarter of a mile ahead of me, doing about 50. I'm doing about 70 already. I'm gonna say I'm doing 80. I gotta back off here. Wow. Smooth acceleration up to who knows what. I caught that truck without any difficulty whatsoever after backing off on the fuel. I smell things getting warm. We're going to check our circulation of our water, how much temperature we get up to. The things I smell getting warm are probably the controller, because it's never been pushed that far, that hard ever. Because it's brand new. I think pieces of paper here, but I'm doing about 50 right now, nice and smoothly. I don't know how well the speaker here is going to catch all this doggone wind. Again, the gauges don't operate yet. We're still programming that into the system. Regenerative braking, I feel it coming on. It's at about 40%. When you take your foot off the gas pedal all the way, regenerative braking shuts down, and I'm probably gonna do something about that. I'm thinking I want it to stay on. I'll have to see if that can be programmed in. This thing really scoots. We got to get the gauges programmed, and then we'll take it on a test drive with another vehicle and set the gauges properly. But we were scooting right along. I think my son's computer is still plugged in, so we can test how many RPMs that I came up to, things like that. But I gotta go up here and make sure that my camera's still on record, because it's so bright I can't see it. There's a weird like
a shutter?
A shutter when the regenerative braking kicks in and out, which is probably
the throttle map is weird. When you're accelerating, you let off, you'll get to a point where there's no acceleration.
Yeah.
You start to let off, you get more and more regen. Then as you get up towards the very top of the pedal,
the regen goes away.
At the most. Then when you let completely off, it drops off completely. That probably shouldn't happen.
Is that programmable?
Yeah, I'm gonna have to change it.
It feels weird.
It goes from heavy regen to nothing all at once, and that's kind of weird.
Yeah, I want more regen the more I let off on the pedal.
You do get that, but the problem is it'll stop when you get to the very top.
I don't want it to stop. I want it to stay all the way. So let me explain what I just did. briefly here, where there's not enough wind where they can actually hear me. I let traffic go past, and I pulled in behind it.
Yeah.
I caught all the traffic before I was halfway to 10 Mile. At such speed, I had to back off for fear of rear-end. I'm not kidding you, for fear of rear-ending cars.
You thought I was doing 45 down this road?
No.
I want to do GPS. I'll bet I was probably doing like 70 or 80 down the road.
Well, you gotta be careful on this private road. I was doing
the gauges aren't hooked up.
I was doing 80 to 90 miles an hour. That traffic's doing 60.
Yeah.
I caught the traffic sooner than halfway to 10 Mile. That's only a mile stretch.
Yeah.
I was coming on them so fast that I had to back off on the pedal. I had to back off on the pedal in order to not overtake them too fast.
Doing too bad on your heat either.
I smelled the controller warming up because it's never been warmed before.
Yeah.
But I want you to check the heat and see how things are warm or not.
The controller might be about, well, it's hot. You wouldn't want to, it's probably 100 degrees on the top of this controller.
That's not bad. But what I'm saying is, I smelled it warming up after I did the
I could smell it.
Then I turned the corner on 10 Mile. I let a truck go about a quarter mile ahead of me. And long before I got to...
You were on the road?
Yeah, long before I got to Sparta Avenue, I had to back off.
How were the brakes?
All right, I'm going to shut her down.
It's all warm.
This thing's quick.
But I didn't do anything nice with the vacuum tube.
You bolted it in?
Yeah.
Built a mounting bracket for the new pump. Sets in here. It's mounted kind of in rubber. Sets up out of the way. This is the existing hose. We're going to add a length of hose longer on here and tuck this in underneath of here and around, but we haven't done that yet. Just moved it over and put it in. We're going to take this, we took this battery out and move it up into here someplace. Talk to the customer. The new motor assembly draws quite a bit more power, pulls down on the batteries really hard. So we are going to we're ordering another set of batteries that will mount down in here. We should be able to put 6 more batteries here. I'm actually able to put a battery here and a battery there that will fall right inside of here should we want to. If you look through the screen next to the mount, there's room right there for a battery pack. There's room right there for a battery pack. Actually 2 right there on that side and 1 over here on this side. So there's places for batteries. This charging unit is capable of 390 what? 390 volts. It's set for 365 now, which is a bit higher than we like for the batteries we have. We don't want to overcharge them. So if we put in 6 more batteries, packs, we'll send this to California, have the software remodified so that this will put out 390, let's say, volts. It will handle the charge for all of the batteries, including the 6 more we're going to put in. It will give us more longevity, give us a little more power on this battery pack. By the way, we didn't mention it, but Colin had, and he didn't know it at first, Colin had programmed this. He remembered 200. He thought that was 200 Newton meters. It was actually, I believe, 200 amps. He regulated the software in here to 200 Newton meters of torque for this controller. It's capable of 300. So he modified it back up to 300. He says this thing is even faster yet. So it's another third. We have not test driven it out on the road, just in the parking lot, I guess, here with that higher power. So I actually put some more stress on the batteries. So putting more batteries in here will stress each battery less. I'll just cut that off. So we're going to swap this hose over for a longer one. We're going to mount the battery that's in here back in this location. We're going to order a new set of batteries, but temporarily until the batteries come in, we're going to do some modifications and test driving with the current batteries that we have. So we'll get back when we get back out on the road. Okay, we're going to try another trip here, except I have to go in forward and not reverse. Collins reset the system. I'll try and hold this out. I'm hearing the brake pump cycle more than I like. I don't know if I've got a leak. Brakes seem to work well. Long story short, my last test drive, I had the camera practically tucked under the dash. We're going to see how long it takes to catch this car. I'm up with the car in less than a quarter of a mile. To talk because wow, I think I shredded every piece of loose paper that was on the car completely off from it. When we get back, we'll find out, based upon RPMs, how fast I was traveling, but I'm going to say in excess of 100 miles an hour. Right now I'm just cruising here, probably about 65. Now I'm going to back off. Regenerative braking, I'm going to back off on it right at this stop sign there. I'm not hitting the brakes. Regenerative braking is pretty much going to stop me by the time I get this stop sign. I'm not even touching the brakes. Now I'm touching the brakes. I'm sure I look like I've been in a wind tunnel, my hair, but that car I passed was doing about 60, 65 miles an hour. And I smoked past him like who knows what. Now, I had to back off on the accelerator after I passed that car to test regenerative braking, and so that if I did get stopped and get a ticket, I wouldn't go to jail. So, I have no proof as to how fast we were actually traveling. For heaven's sake, I hope they don't post this internet, because then I'm going to be in trouble. So she moves right along, there's no doubt about that. Colin's got his laptop in here to record. Hopefully this on the camera passing that vehicle. Yeah, regenerative braking is working very, very nicely. Turn signals are not wired because I didn't see them flashing. I used them, but I don't think they were working. Pretty much any loose piece of paper that wasn't glued down well on this car pretty much blew away in the wind. I saw pieces coming off and going past my head. Acceleration is quite intense, actually. It's no Tesla, but we're 0 here, and I'm on the floor right now. I'm doing about 50 right now. The vacuum pump pumps too much. The brakes don't seem to be as grippy as I like. Kind of check that booster power and stuff. But I went so fast, I think I shook every piece of paper or ripped it off on here.
I know, it's all...
There are debris of paper behind me. I caught up with that car that was out there.
Yeah.
Within a quarter mile.
You need to pull all this paper off.
We probably should pull the paper off. It's just getting...
And I went past that car at least 30 or 40 miles an hour. Past that car. I accelerated for about another 200 yards. And then I backed off in order to make, because I was at 10 mile before I knew it.
Right. This paper here is already pretty well...
Well, if we're gonna be leaning over the car...
The problem is it's got like grit stuck to the bottom sides of some of
Yeah, but if we're gonna be leaning over the car, I want it on top. I don't care if you tear it off the sides. A lot of it blew in the wind.
I'd take it all off.
Yeah,
Pieces were flying over top of my head.
The sides is just ripping right off because of the wind shear.
Yeah, I'm telling you, it was... This thing is quicker than the last drive.
It is. It gets right up and going now.
We may have to have that booster checked.
People told me it wasn't going to work direct drive, but they were wrong.
No, watch. I'm in forward mode, okay?
Yeah.
I'll stop at the mailboxes. You tell me about how fast you think I'm going by the time I hit there. Ready?
You got a cigarette lighter in here?
I don't know, why?
But it's not hooked up currently.
Oh. Gus, throw a GPS.
Wow. That's awfully good acceleration. Awfully good acceleration. I'm doing 50, 60 already. This is a private drive that we shouldn't be going that fast on, so. Huh?
Have you been testing the regen as well?
Yeah, it doesn't seem to work at like 10 or 15 unless you already were in regen, then it darn near stops you for the stop sign.
Yeah.
Regen's pretty good.
It regens good at high speed. I intentionally turned it down at low speeds. I might have to tweak that a bit.
We're going to check the braking capability.
That's a lot of reverse torque.
Just about standing on that pedal, though.
I'm hitting the pedal pretty good.
Yeah. I think it's getting better than it was when I
But it could be glazed up. Could be glazed up brake shoes too from sitting.
Yeah.
Yeah, your brakes are improving. You were garbage. 1958.
All right, we're back. Man, this thing flies. We're back. I just did 2 hard runs. Radiator is 107 degrees. 101.
And that's very impressive. Good work, guys. I think they're on to something there. No, I don't like direct drive, but it's primarily they would have much greater acceleration. Not where it's apparently important to them. 0 to 20 is going to be a little tame for most people, I think, but they do have a 3.91 to 1 differential gearing, and that Siemens motor, not the Siemens motor, they are using the UQM Power Phase 100, which is proven to be a very nicely sized motor for many of these applications. It produces a lot of power. It's physically small and light and quite smooth. And they are showing that to good effect in the SL190. Apparently got it up to 108 miles an hour with great acceleration from 20 to 50, say, or from 50 to 100. As you get up in RPM, that low ratio starts to work extremely well. And so at highway speeds, this thing has great acceleration. The only place it's going to show up is as a problem is at the bottom end, and they seem quite satisfied with what looked to me fairly tame acceleration. But that's in the 0 to 20 range. And, when you look at the way people drive, I'm not sure they're not onto something there. Why would I need to go fast from 0 to 20 or 30? It's really moving out of city traffic and onto the on-ramp where you need acceleration in a modern traffic situation. And with 3.9 to 1 at 5,000 RPM, this thing will be going great guns. And clearly they were tearing the paper off of it. So a very good result, I think, and we'll continue to watch that. We now have 2 out there. I embarrassingly have not completed the VW thing with our UQM, but I wrote most of the option module, the object module for the UQM that's in the JevQ. And Colin, of course, did the breakthrough on the security byte on that thing. And so we worked on it together. I actually implemented the rest of the software in the JevQ, and it seems to be running very smoothly. And so Rich Morris up in Wisconsin is doing pretty well with his Studebaker pickup truck, 1960 that you saw. And now here's a 1 year older Mercedes-Benz driving with the same motor. And so I think we're going to see the UQM Power Phase 100, which has been a slow seller and is one of our more expensive drivetrains, but it's starting to look pretty good on the road. It works very well. And so that about wraps it up. We've done a lot about Tesla. We're very excited. In fact, I got to say I'm pretty much distracted totally by the Tesla drive unit, and we'll be working on software for this week. But I thought I'd talk about some of the more readily available. I'm just not very commercially driven. We've got a lot of toys around, and some of these guys struggling with stuff that just doesn't need to be struggled with. And so I thought I would at least mention them. But we're very, at this point, I'm quite engaged with the Tesla drive unit. We have it down to 7 messages, 3 involve regen, and the other 4 are required to actually start and operate the motor and controller. That's out of 164 that the car was putting out. There's 23 messages coming from the inverter. One of them already has torque and RPM, and I'm half done with everything I need to know there. I need about 4 or 5 more things. I'd like to have 2 temperatures, voltage, current, and that's about it that I need to know from that inverter. We're not beyond that. I'm not going to bother decoding anything because I don't need the information. I don't know what they're talking about and don't care. I want voltage, current, torque, RPM, and 2 temperatures, inverter and motor. And after that, I don't care what they have to say. Their fault status doesn't do anything for me. I can tell when it rolls to the side of the road that we have a problem. So we're kind of getting pretty far down the road on the Tesla. The big one I was struggling with was just what gear it's in, park, reverse, neutral, or drive. And that one's kind of over. We're there. There's some targets of opportunity we'll probably spend some time on. Could we vary the level of regen? Can we vary the power output? I mean, we can with the range mode and the standard mode. Could we go beyond that and get even more power out of it? Could we, for example, be able to continuously vary the regen instead of having 2 points to? So there's a lot of questions, a lot of experimentation, all of it fun, and it's going to be fun developing the software for it, and I think it's going to wind up being a breakthrough product that literally 2 or 3 years from now, a lot of people are going to be on the street with conversions they've done with a Tesla